we have done some basic mathematics. Now we will start from here to understand what is my decision rule for the classification. What should be the decision rule? Decision rule mean, just assume a scenario. You have a set of points in this side. You have some another set of points in this side. You will have some classification boundary, obviously. Just for understanding, we will discuss everything in 2D. Okay. Because instead of 2D, if it is 3D or 4 or 5D, the equation will expand a bit, but the strategy remains same, right? So that's why we will discuss in 2D so that it's easier to understand. So we have two features, x1 and x2 here, or two dimension, whatever you can say. We have some set of points to either side, and we have a classification boundary here. And what we want to do, we want to find out the decision rule by which we can decide whether a point is in this side of the boundary or in the other side of the boundary. I mean, it's +1 or -1, something like that. So just to understand this, just assume a scenario that we have a points here which is a vector definitely, and this is nothing but a perpendicular vector to this particular decision boundary. Again, I'm telling you, you see, it came again. Just what we have seen, the perpendicular vector of this particular decision boundary. And we have another point here, another red point, which I represent as capital U. Obviously, this particular red point will have two components, one from x1 and one from x2. Okay. So just assume that the distance between this origin origin to this yellow point is, say, C. So this is the value of this W. Okay. And what I want to find out whether this U is this side of the boundary or the other side of the boundary. I want to find out. Okay. Just try to understand. You want to find out whether U is in this side or this side. Visually you can see here. But how mathematically you can understand? With respect to equations and values. If this particular diagram is not in front of you, then how you can do that? You have to do some computation. So how to find computationally? You have to understand that, right? Now you see, to understand this, first of all, we have to check what is the length of U. Because we all know the length of W is C. If the length of U is less than C, then that mean it is in this side. If the length of U is greater than C, that means it is in this side. It's very simple. But problem is that the direction of U is different than the direction of W. Right? So first thing that we have to do is that we have to make a correction on the direction of U. So somehow, in other words, you can say we have to project this particular U vector on W vector, so that the direction become same. Once direction becomes same, then we can easily compare by its value. Now, if you can recall about the vector algebra, a very basic vector algebra, if you have two vectors, v1 and v2, and if you want to project the v2 vector on v1, what we do? We actually do a dot product between v1 and v2. That's the idea, right? So that means here also, when we will try to project this u on top of this w vector, it will be nothing but w dot u. It's a dot product between w and u, right? Now I'm assuming that this side is positive and this side is negative. Okay, just assume for time being. So You see, if this particular, after projecting u on w, after doing this dot product, the value that we will get, if the value of this is greater than or equal to c, that means I am in positive side, otherwise I am in negative side. So that means the vector u to be positive, I must have an equation something like this, that w dot product u should be greater than equal to c, where c is the value of w, I mean the length between this origin to this vector, I mean length of the vector actually, you can say, right? Also, let's make little more clear, wu minus c greater than equal to 0, right? So in other words, you can say that in a very general form, you can say the equation should be w dot u plus b greater than equal to 0. You know, b is simply a constant, which is nothing but equal to minus c. In this case, you can say the general form of our decision rule can be defined something like this. So this is, you can say, the decision boundary based on which we can decide in which side the particular point lie. So that means if w dot u, after projecting u on top of w, if you see the value is less than 0, that means surely this u in this side. And if this point is somewhere here, when you will project this particular u vector on the top of w, you will see that it will be greater than equal to 0. So naturally, the point will in this side. But let's do one thing. It will be much more clear if we take an example. Suppose we have a problem like this. You know, I don't have this diagram with me. I have simple question that find the position of red points x 0.51. So 0.51 is the point of red, I mean location of this red point. And equation of the boundary is 3x1 plus 2x2 minus 8 equal to 0. This one. Equation of this, green boundary. Okay. So I have a simple equation. It's like w1 x1 plus w2 x2 plus w0 equal to 0, where w0 is equal to minus 8 here, right? So I hope you can easily understand here, the capital W will be equal to this one and capital X will be this one and this b equal to minus 8, what just I mentioned. Now if you want to apply the dot product between w and x vector, it means actually a multiplication between w transpose and x, as simple as that. We have already seen. So what we will do, we will just do simple multiplication between these two vectors, right? Anyway, it should not be in this way. Actually, it should be x should be a column vector, something like w as well. And somehow by mistake it was represented in a wrong way. It should be in a column vector like this, like w. Anyway, now I have the value of w, ax, b, everything in my hand, right? Because what is w? W means actually w1 and w2. It means actually 3 and 2. X means actually x1 and x2, which is 0.5 and 1, because I want to find out position of this red point. And I have this b. So just simple put it. 3, 2 dot 0, 5 and 1 minus 8. Anyway, it was wrongly written here. It should not be like this. It should be 3, 2 in as a row vector, then as a column vector 0.5 and 1. Anyway, as a result, what you will get? You will get a value minus 4.5. And minus 4.5 is less than equal to 0. It means that this particular point which we are trying to find out the position with respect to the decision boundary, it's in a negative side. That's all. So in this way you can easily find out the location of any point by the equation of the decision rule. Now what we can do? We can utilize this decision rule further to understand how we can, calculate the width of this margin, that is the difference between these two line.